Okay, here we go. Last section in chapter 6, 6.6. So now we're going to add the last transformation of the sine curve. We're going to add this a in the front, and it's going to work exactly the same the way it did with parabolas. A actually stands for amplitude. So amplitude, you'll remember, is the distance from the axis to the peak, or the distance from the axis to the trough, the lowest point. So I'm going to show you how that's going to play out, okay? So first one we're going to look at is what happens if we have a negative in front of sine x. Okay, so always a good idea to draw your regular sine curve. So negative sine x works the exact same way. So normally the sine curve starts by going up. The negative sine x curve is going to start by going down. Okay, so we're going to go down to -1, back up to 0, then up to +1, and back down to 0. So when I connect that, it's the exact mirror image of sine x. Okay, so that's what negative sine x looks like, and that's what the a value when it's negative. Instead of start by going up, it starts by going down. Okay, so let's take a look at 1/2 sine x. So what happens if there's a fraction in front? Okay, so the starting point, because there's no left, right, up, or down, we start at the same point, but instead of going up to 1, we only go halfway up. That's 1/2. Back down to 0, only -1/2, and then back to 0. So it has half of the amplitude of the regular sine curve. So that's 1/2 sine x. Sorry, I'm just labeling them there. Okay, so you'll see that. Okay, and then the last one in this one is -1/4 sine x, but we moved it up 3. Okay, so we're going to apply this movement first and then apply the amplitude. Okay, so normally it starts at 0, 0. If it's moved up 3 units, the starting point is now there. Okay, so that's what the +3 does. There's no left, right. There's no bracket. Okay, and then we apply the -1/4. So from there, we're going to go 90 degrees over. Normally, we'd go down 1 because it's a negative, but we're only going to go down 1/4 of the way. Back up to 0. 270, we're going to go up 1/4. And 360 back down to the axis, which is 3, right? So connect it. You'll see that the amplitude is very low. So this is f at x equals -1/4 sine x. Sorry, there should not be a bracket there, +3. Okay. Forget the bracket because there's no left-right movement. Okay, so we start up at 3. And then we apply the -1/4. So we go down first 1/4, back up to the axis, up 1/4, back down to the axis. Okay, so that's how you deal with it. You're going to relocate that vertex or that starting point first, then apply your amplitude. Okay, so now let's do 3 more. Let's see what happens when we have a bigger amplitude. So let's start actually with this one, 5 sine x. So normal sine x goes 0, 0, 91, 180, 0, 270, -1. I just changed the scale on this one so I could fit everything. Right, so if this is our normal f at x sine x curve, the 5x just means it starts at 0, 0, but at 90, instead of going to 1, it goes all the way up to 5. Back down to 0, down to -5. So this one's got a huge amplitude. Okay, and then just sketch it. And it would continue on and on and on, right? This is a continuation. So that's f at x 5 sine x. That's what happens when we change the amplitude to 5. Normally it's 1, but we change it to 5. Okay, so that's what it looks like. Let's try this one. 2 sine x plus 45. Okay, so the plus 45 means we're going to go backwards 45 degrees for the starting point. There's no up or down movement. And then the 2 means that the amplitude is just going to go up to 2 instead of its normal 1. So if that's our starting point, which is left 45, we're going to take every point and go left 1.5 squares. And then up, instead of 1, we're going to go up to 2. Okay, so from 90, we're going to go to 45, which would be here, and 2. 180 would go over 1.5 squares, so everything's shifting to the left. 270 would go to halfway there, and then down to -2, and 360 back to the axis. Okay, so this is what it looks like. Sorry, I'm doing it all on the same graph. It's just to make it a little easier viewing. Okay, so that every point is shifted left 45 degrees, and the amplitude is changed from 1 up to 2, and if it's -1, it's -2. Okay, so that's that one. So that's f at x equals 2 sine x plus 45 degrees. Okay, that's what that looks like. And then the last one, when we put all three together, we can have multiple transformations. So -3 x minus 90 minus 4. Okay, so let's take this one step at a time. First, let's relocate the starting point. So from the starting point that's normally 0, 0, we're going to travel right 90 and down 4. Okay, so let's do that first. So right 90 and down 4. This is my new starting point. Okay, so once you have the starting point, you know what the curve is going to generally look like. Now you just have to apply the amplitude of -3. So normally we'd start by going up. This time we're going to start down. So from 4, we're going to go 90 degrees over. So to travel from 90, the next point is going to be dropped at 180. And it has an amplitude of -3, which would be down here. Back up to the axis, 90 degrees later, up 3 and 360. That's the next 90 over. And then another 90 over and back to the axis. So this one looks like, because it's upside down, Okay, so this is f at x -3 sine. Okay, so it starts negative and it goes down 3 and up 3, the amplitude. We moved it right 90 and we moved it down 4. Okay, so that's that one. Got a little messy up in there, but obviously you do yours a little bit better. Okay, so these are all the transformations put all together. Try them out, work on them. The back of the book has some answers for you there. And again, I'll be online if you have any questions, okay? So on 373, do numbers 1 to 5. Pass it in at the end of the week along with 6.5, and that will be it for this week. Okay, hope everybody's doing well, and we'll talk soon.